Partial fractions. In pre-calculus algebra, you dealt with partial fractions, how to take a rational expression and decompose it into individual or single fractions, whereby you're able to, here for our case, integrate easier. Well, we use the concept, and the main concept here in this section is to be able to recall from pre-calculus algebra how to decompose rational fractions into partial fractions, or the sum of partial fractions. Steps here, just two, I think, and much of it is to recall from algebra, but one, decompose the rational expression by the method of partial fractions, and then secondly, integrate the individual fractions, and that should be easy. We seek to integrate the following as an example. You want to integrate this particular integral, and notice that the fraction, the rational expression, can be decomposed. Well, it's the process of going from this left side to the right side. That's the partial fraction decomposition that you talked about in algebra. And then after that, you integrate the left side, which is applicable to integrating here two partial sums. And the result of the right side is the result of the left side. Just something, a statement for decomposition or decomposing the numerator divided by a denominator or a rational expression into partial fractions. This statement, numbers 1, 2, 3, and 4, they come identically. It's an identical copy from the algebra book. I kid you not. So when I teach the algebra and I teach this, we'd go over these steps 1, 2, 3, and 4. It's the same exact thing. So since we have an idea of that, let's look at it. And as I work the problem, we will recall and do those first emphasis that we should to be able to get to the end result of being able to calculate the integral using partial fractions. So we take this term, and the example in the book was pretty neat because the author went over how to substitute using trigonometric forms to be able to get the result, which you recall from the previous section is a very long process. Is there an easier way? There is. So here we take the rational expression 1 over x squared minus 9, and we're going to just break it down, see if we can get some factored terms, x minus 3, x plus 3 for our denominator. You want to be able to form some generic term a over x minus 3 plus b over the other term in our denominator, x plus 3. Once we find a and b, then we integrate these partial sums to get the result for the integral. That's the question. So we look at this expression, and from the method of partial fractions, you multiply both sides here by the least common denominator, which is x minus 3 times x plus 3. This implies then we have 1 is equal to a times x plus 3 plus b times x minus 3. When the terms are broken up into this fashion here, then it's easy to solve for the generic terms. Say, for example, if you let x equal to negative 3, then we can infer or produce the value for b. And then after that, we'll let x equal to 3 to be able to solve for a. So here, let x equal to negative 3. This implies then that we have 1 from the left side is equal to a times 0 plus b times negative 3 minus 3 is negative 6. So here, this implies that 1 is equal to negative 6b. b is equal to negative 1/6. So we need that. Well, the second thing we do is we say let x equal to 3. This implies that just plug in x equal to 3 everywhere you have x. We have the left side 1 is equal to a times the expression 3 plus 3 plus b times 0. So here, this gives us 6a equal to 1. That implies that a is equal to 1 over 6. Now don't get to thinking that these terms will always be opposite. Sometimes that's not the case. So this integral breaks down into its parts. This is the integral of a, which is 1 over 6 over x minus 3 dx, plus the integral b, which is negative 1 over 6 all over x plus 3 dx. Now it's easy to calculate those integrals there. So we can write this as 1/6 times the integral of 1 over x minus 3 dx minus 1 over 6 times the integral of 1 over x plus 3 dx. We get just natural log, so this is 1 over 6 times the natural log of the absolute value of x minus 3 minus 1 over 6 times the natural log of x plus 3 and then plus c. Now you can leave the answer as that, or you can combine those two natural logs. It doesn't matter with me. I don't think he's particular in Weber sign as well, so we'll just leave it as that. So here we're going to break down this fraction. We have 5 over, let's see if we can go ahead and just factor here. Excuse me. X plus 4 times x minus 1. We write this as a over x plus 4 plus b over x minus 1. Multiplying both sides by the LCD, this produces for us 5 is equal to a times x minus 1 plus b times x plus 4. Let x equal to 1, solve for b. After that, let x equal to negative 4, solve for a. So let x equal to 1. This implies that we have 5 is equal to a times 0 plus b times 5. And doesn't that give us b is equal to 1? 5 is equal to 5b, right? Secondly, let x equal to negative 4. So this implies that 5 is equal to a times negative 4 minus 1 plus b times 0. This implies that a is equal to negative 1. 5 is equal to negative 5a. So a is equal to negative 1. So that be the case, then we have the integral of a, which is negative 1 over x plus 4 dx, plus the integral of b, which is 1 all over x minus 1 dx. So this gives us negative times the natural log of the absolute value of x plus 4 plus the natural log of x minus 1 plus c. What I was saying before about writing the natural log as one expression, you can write this as the natural log of the absolute value of x minus 1 all over x plus 4 plus c. Remember that minus denotes for the natural log that this is this term here would be in the denominator of the quotient. And you could have applied that up here for this problem as well. So you could write this as 1 over 6 times the natural log of x minus 3 over x plus 3 plus c. Either answers are sufficient. Let's look at this problem. It's a little bit more involved there, but we still use the same method. So this is x squared plus 12x plus 12 all over. I'm going to factor that. This x times, that's x squared minus 4, so that becomes x minus 2 times x plus 2 for our denominator. So this looks like a over x plus b over x minus 2 plus c over x plus 2. Now, why the a, b, c? I should have said that maybe for the first problem, but again, I'm assuming that we do recall a little bit of the knowledge from algebra. That is, that the terms downstairs, the factored terms downstairs, if they're linear, then the term that goes in the numerator is 1 degree less than that form. So if downstairs, if I have a linear term, x to the first power, then you got to have a constant term up top. Likewise, x minus 2 is linear. The term up in the numerator is a constant, 1 degree less. So now there's some of the problems where you may have an x squared downstairs. Well, if that be the case, then your numerator is of the form ax plus b, which is said to be the standard linear form, right? So if it's quadrature downstairs, it's linear up top. If it's linear downstairs, it's a constant term up top. If it's a cube form in the denominator, then it's a quadratic form in the numerator, which we haven't crossed any of those. Typically, it's either constant in the numerator, linear downstairs, or linear in the numerator and a quadratic downstairs. So here, take this expression, multiply both sides by the LCD, and what that gives us then is this. The numerator for the left side is x squared plus 12x plus 12. That's equal to a times, multiplying both sides by the LCD, that's x times x minus 2 times x plus 2. Then multiply this fraction by that LCD. The x's cancel out. You have left x minus 2 times x plus 2 plus b times, well, this has x minus 2. Divide that by the into the x times x minus 2 times x plus 2. You have left x times x plus 2. Then plus c, it doesn't have downstairs an x times x minus 2. Okay. So three things that we're going to let. We're going to let x equal to 0, let x equal to 2, and then thirdly, let x equal to negative 2. So first, let x equal to 0. This implies I plug in 0 everywhere I have x. So the left side, I have 12 is equal to a times negative 2 times positive 2. Plus b times 0 plus here c times x is 0. So that gives us, yes, 12 is equal to negative 4a, which implies that a is equal to negative 3. Now, secondly, let x equal to 2. We're doing that for this expression over here. You can't do it. See, the left side here implies the right, but the right side does not necessarily imply the left, right? Going back. So let x equal to 2. This implies that the left side, we get 2 squared plus 12 times 2 plus 12 is equal to a times 0 plus b times 2 times 4, then plus c times 0. So the left side we get 4 plus 24 plus 12 is equal to 8b. Not Aunt B from the Andy Griffith Show, but 8b. Good. So we get 36 and 4, so we get 40 is equal to 8b. This implies that Aunt B is no more, and b is equal to 5. Now, let x equal to -2 for this expression here. You can't plug it in for these fractions, you get something that's undefined. The left can imply the right, but it's not necessarily true that the right implies the left. A implies B or P implies Q could be true, but it's not necessarily true that Q implies P. P implies Q. Not necessarily true that Q implies P. The converse is not necessarily true, right? Okay, good. I was just trying to think of a simple statement of logic to show that. If it rains, I take my umbrella, but if I take my umbrella, it does not necessarily imply that it's going to rain, right? Just because you have your umbrella, it's not going to make it rain. Okay, kind of sorry example, but anyway, you get it. La, 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 la. Okay, so we plug in -2 for x, so we get -2 squared plus 12 times -2 plus 12 is equal to a times, that -2 here is going to cancel out, so that'll be a 0 plus b times -2 plus 2 is 0 plus c times -2 times -2 minus 2 is -4. So we get, yes, we get 4. This is minus 24 plus 12, and that's equal to positive 8c. So this implies that we have minus 12 plus 4, so that gives us -8 is equal to 8c. And that implies then that c is equal to 1. So I think we have everything that we need. So this is the integral of the a over x. A came out to be a -3. I'll put that right there in the front, -3 of the integral of 1 over x dx. Looking at this, replacing a, b, and c, these generic terms with what they are. Okay. Then plus b, which is 5. Don't know why my screen is looking like that. So 5 times the integral of 1 over x minus 2 dx. Then plus the integral of c, which is 1 over x plus 2 too much. Dx. So now this is -3 times the natural log of the absolute value of x plus 5 times the natural log of the absolute value of x minus 2 plus the natural log of the absolute value of x plus 2 plus c. And you should be fine with that, with the answer for the online input for your results. I mean, if not, you can write the answer as Yes, the natural log of the absolute value. The terms that are together would be, for the numerator, would be the x minus 2 to the 5th power times x plus 2. This is all over x to the 3rd plus c. Either way, but I think this one should be fine. Okay, now I didn't want to do this guy, so I wanted to keep the time like we had it, but we'll go ahead and try to tackle it. This is 4x squared plus 2x minus 1 all over. Factor downstairs, that looks like, well, this is a good one. This is x squared times x plus 1. So the terms downstairs are linear, but if it's repeating, then you have to do something a little bit different than how you write the result. So I think this is good. So this is a over x plus, here the x is repeated, so this is b over x squared. You do that for repeated terms, right? Then plus c over x plus 1. Well, I guess it was good that I did this. Multiply both sides by the LCD, and when we do that, we end up with the numerator of the left side is equal to a times x plus 1 plus, as one of the deacons said at the church, oh boy, times b times the expression x plus 1 plus c times x squared. Right. You can let x equal to 0 and x equal to -1, but that'll give us two of these generic terms, two of the ABCs. For the third one, we have to equate everything out and equate the left side equal to the right side and solve for the terms that way. That was the old-fashioned method, the method that I learned in high school. So let x equal to 0. This implies that the left side is -1 is equal to, this is a times 0, and that's c times 0. So all you have left is, oh, excuse me, this is a times a 0 because x is -1. I'm crazy. X is 0. I'm looking at this -1 here. That -1 comes from letting x equal 0 here, x equals 0 there, -1. So x is 0. This is 0, that's 0, so it's b times 1. So that's b and not a heart, right? B. So b is equal to -1. Now, yes, let x equal to -1. Because here, -1 to cancel out this x plus 1, and to cancel out this x plus 1 there. Let x equal -1, so the left side is 4 times -1 squared plus 2 times -1 minus 1 is equal to a times 0. X is -1 plus, no, b, not a heart, a sideways heart. X -1, this is b times 0 plus c times -1 to be squared. So we get 4 minus 2 minus 1 is equal to c. So we get 4 minus 3, so c is equal to 1. Now, so what is a? I don't know. Okay, this is the a there. So what we do is we look at this equation here, and the statement is that if this equation is true, then the corresponding parts from the equation, from the left side to the right side, are equal. So with an equation, the corresponding parts are equal. So here, to solve for b, we use the fact that the corresponding parts from an equation are equal. So we take this equation, we have 4x squared plus 2x minus 1 is equal to, we simplify, we expand everything out. This is ax squared plus ax plus bx plus b plus cx squared. I get all the corresponding terms together. So notice here that this is 4x squared plus 2x minus 1. Get all the x squares together. So this is 4. It's a 4? It's an A. Doggone. Can't even read my own messed up writing. Lord help me. This is A plus C times x squared plus, and then for the x's we have A plus B times x, then plus the constant b by itself. So here x squared is the same as x squared, so the corresponding parts are equal. So 4 is equal to A plus C. 4 is equal to A plus C. Likewise, x is equal to x. So 2 is equal to A plus B. 2 is equal to A plus B. And then negative 1 is equal to B. Negative 1 is equal to B. We're done. Right? Because we're looking for B anyway. No, or to solve for B. Oh, sorry. Solve for A. To solve for A. We got B is equal to negative 1 there, Ernest. We got C equal to 1. So to solve for A. So we're not done. Okay. So wasn't erasing that. Not necessary. Erasing the wrong thing. Yes. To solve for, I got B and C. I need A to solve for A. No problem. Yes. Notice that you got B equal to negative 1, which you knew that already up there, right? But back when I was in school, we didn't use this watered down method. Everybody uses this watered down, not so strong method. This was the strength because back then we used systems of equations to solve. But anyway, you got 4 equal to A plus C. If you know C, you can solve for A. Well, C is 1. So we get 4 is equal to A plus 1. A is equal to 3. And it should be consistent. And you can stop there, but it should be consistent. B is equal to negative 1, right? B is negative 1. So here you have 2. Well, you get negative 1 for B there as well. 2 is equal to A minus 1. And so A is equal to 3. Well, we knew that, and you didn't have to do that. Just wanted to show you how strong our old method was. So A is 3. B is negative 1, and C was equal to 1. Yep. So we integrate, and this is good. I'm messing up. I guess I better leave that alone. Maybe I can come here and just put the result. I'm trying to copy so I can remember these terms, but anyway, this is the integral. The A is 3 over x dx. The B is negative 1, so this is minus the integral. I'm going to write this 1 over x squared is x to the negative 2 dx. Then the C was 1, so plus the integral of 1 all over x plus 1 dx. Okay. So we integrate. I need more space. Can you see this color? Let's see. So this is 3 times the natural log of the absolute value of x. Integrate x to the negative 2. That becomes x to the negative 2 plus 1, which is just x to the negative 1 divided by negative 1. Negative divided by negative is positive. This is 1 over x plus the natural log of absolute value of x plus 1 plus c. And it looked like it took me to go all around the world. All around the world, same. So I wrote that so small. Let's see if I can write it down here. I remember, because my mind is so small. 3 times the natural log of x plus 1 over x. Is it a plus sign? Plus the natural log of x plus 1 plus some constant c. I think that'll do it. Thank you.